Hey, welcome everybody to our next episode. We had a question this time. I checked the spreadsheet. Robert had a question. Yeah, last time we talked about the tar to H5 converters. And the question is, right, does the standard compactor simply skip the 64K tar file entries if ones are encountered? Yeah. Or must they all conform? And also, what is a typical range, on the number of files extracted / converted? Yes. So I actually looked at the code because I haven't looked at the code, and the code is actually not perfect. It could use a lot of improvement. But if I look at the code, I would say the current code will actually skip entries that are greater than 64K, because if you look at the code, there is this if statement where we say, if the what it reads is less than the buffer size, it will then try to create a data set and so forth. And where the criterion is pretty much, as if I remember correctly, that the size of the buffers, the number of bytes read is less than, in this case, a 1 megabyte buffer. And then I think it also checks the creation, the H5D create on that compact data set, and that will fail in this case. It will not trigger an assertion, it will fail. So you would probably see an error message from the HDF5 library, but it will just continue on from there. So I think that logic can be improved substantially and made more robust and so forth. But that's why it's better to run first this archive checker that really will print information if there are files encountered that are greater than 64K. And to the second part of the question, I know that my sort of partner in crime, when we did this, he used it with like tens of millions of small images. So he had this tar archive that was for some kind of training data set. And yeah, he used it with tens of millions of images.
Okay.
Does that make?
Okay. Yes.
Okay.
Gerd, do all of those compact data sets, do they all fall under one top level group, or is there any attempt to? Okay,
yes,
so
yes, as far as I remember, because remember last time we showed the output here from oh no, it was actually on the GitHub page where we show the HDF Compass output. Let's see, where did I have that? Am I going back? Oh yeah, here we go. I'm just gonna open a new tab and go over there. If you scroll to the bottom, yeah, so this is the compactor output, and then you see it's under the root group that all these, the name in the archive is used as the name of that compact data set. So these were all JPEGs. And if you do the SHOR1, then yeah, it will also delete duplicates, but it will use the SHOR1 string as the name of the data set. And then yeah, if you do the shredder, then it will break it up into image and name data sets plus the respective offsets.
okay. Okay, thank you.
Yeah, you're welcome. And of course, if we would redesign this, and at some point I'll probably rewrite it, there's not that much code. I would probably put it into a subgroup, because right now you cannot impose any sort of additional properties on that group. There is no group creation property list for the root group. This is something I think we will fix maybe in future versions, because there's nothing special about the root group. The root group is like a group like any other group. So it's just, yeah, it sort of gets created by default. But you should have a similar level of control that you have over any other group. And okay, well, thanks for the question. And yeah, there's plenty of room for improvement on those tools, but I think they are fundamentally useful. They are just a nice touch to show people who otherwise settle for a lot less if they don't use HDF5. And yeah, okay. Unless there are any other questions right now, I'll just go through the usual motions. Okay, good news is the webinar, the introduction to HDF5 for HPC took place, and the video recording is available online. I linked it here, and yeah, it's a great. I started watching it this morning, but I couldn't get through it because I think it goes for almost 2 hours or 1 hour, 2 hours. I forgot. I didn't have that much time this morning, but I'm gonna definitely watch it. I think Scott does a great job of presenting these things. We will have another webinar on Hermes, just sort of an update on progress. The Hermes, this buffering system, distributed buffering system. I know Chris Hogan is gonna show something on the thing that we call the buffer organizer, and then just an update on VFDs, and so lots of things to talk about. And yeah, you can register for free. It's gonna happen on Friday, August 5th at 11 Central. But yeah, there will also be a recording. So if you have to miss it for whatever reason, yeah. Okay, I'm going to pause. Any other question? Otherwise, we will move to the forum and a few other things. No? Okay. Again, my biased selection from the forum was basically two things. One, I converted into tips and tricks, and the other one is here. That is sort of an interesting, a user was asking about, he tried to store variable length lists of strings in an HDF5 file, and he couldn't make that work somehow with Python or with H5Py. And the first question to ask would be, well, what's a string, or what did the user think is a string? What was a string in the user's understanding? And what he meant was really, in his understanding, he wanted really to look at a string as an array of characters, not as a string. So if you go with that, the user means that, okay, to me a string is not, if you take a string literal like double quote or single quote, pick your favorite, A, B, C, D, E, F, G, quote or double quote, but rather an array of single character strings, single quote A, quote, comma, single quote B, quote, and so forth, then that's of course a possible definition, and you know, that seemed to make sense to the user. So which means in his definition, when he talks about variable length list of strings, what he means is a variable length list of strings is a list of arrays of characters of varying length, list of varying length, and then the elements of that list are arrays of characters. And of course, this is not the same as when in HDF5, for example, you create a data set whose element type is variable length string, because a variable length string in HDF5 is not a list or an array of characters. And so my colleague Aleksandar actually clarified that for this user, and provided a little example here where, yeah, he creates 4 lists of strings that are, no, he creates 4 strings that have different lengths or sizes as lists, and so 3, 8, 6, and 4, and just randomly, and this is how you do it in H5Py. So you basically have to use, yeah, this D type, which is basically a variable length data type where the element type is a single character string. That's what NPD type S1 is. It's a single character string. And then you use that to create a data set with that element type, and then that was actually news to me. I'm not up on my Python here that there is now this sort of maybe in Perl or PHP. I remember seeing that for the first time. This, well, yeah, you have sort of a loop index, but you don't want to give it a name. Call it the lambda expression of the loop loop indices. Anonymous, you might almost call it an anonymous loop index. I didn't know that Python had that nowadays, but yeah. And then, yeah, you just randomly create a character sequence and then store it. And that works. And then so the H5 dump output you can see. So there are 4 variable length strings in the user definition. The first string consists of the characters G, B, and X. And the next string consists of the characters K, J, U, blah, 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 until T, and then, and so forth. So that was, I think, instructive. And yeah, I mean, variable length string has a well-defined meaning in HDF5. It's not exactly the meaning that is necessarily shared by everybody, and that's okay, but you can still make work if your definition of a variable length string is just an array of single character, an array of characters, if you wish. Okay. And that was it. I mean, there are always lots of other things on the forum, build issues, the Go stuff that we talked about last time, that was resolved. And but yeah, this is a very biased selection. But I'm gonna, since we have Dana here, that's always a great way to check in what's going on in the engine room. In engineering, there is this thread going on, of course, what people would like to see in 2.0, but then also I think there were some changes in the, not so much the release schedule, but what's going to be in the upcoming 1.13.2 and 3 releases. Dana, do you want to say something?
Yeah, so for the releases, we're going to be releasing 1.13.2 in the next couple of weeks, and that's going to have the Onion VFD in it. It has subfiling and it has selection IO. And so that's a little bit delayed from where we originally thought we were going to do it at the end of July, but it was because we realized that subfiling was ready early. So we wanted to get that out because that's on ECP critical paths. So we wanted to get that into a released experimental version. So that's coming out. And then the change there, though, is, besides just the slightly delayed release, is that VFD Swimmer is going to be kicked to 1.13.3, which should come out in October. And that's because it has a bunch of technical debt that needs to be addressed. So that we'll do that over the ensuing couple of months, and we'll get that out in October. But yeah, other than that, the releases seem to be on track for release of 1.14 at the end of the year, which right now it says it's going to be in December. It's not going to be in December. It's going to be hopefully before Thanksgiving, because I don't want to ruin Christmas. So I try to not target anything for the month of January or December, because no one's around. As far as HDF 5 2.0, I don't know if I've ever mentioned it here, but what we're trying to figure out what to do in terms of pointing the library in a particular direction after 1.14 releases. 1.14 is really a big part. I mean, there's these new VFDs, the Onion VFD and the VFD Swimmer, but a lot of it's really about ECP features. And so in HDF 5 2.0, we're definitely going to have semantic versioning, so we're going to switch to having the first number actually increment for the first time in the history of HDF5, which people have been asking for a long time. But other than that, like, what do we want to do in terms of the scope of HDF5 2.0? For me, I feel like we should really try to get HDF5 2.0 out sooner rather than later, and kind of do a bit of an API rethink in terms of how some things are handled. We don't want to break a lot of people's code. We want to keep it as sane as possible, but there's definitely some choices that were made that were not the best. And so I'd like to address those. I mean, just things like there's a few API calls where we return library allocated memory, which is unusual for the library. So we want to make it so that those go away. Potentially also changes to the filter interface so that we can be saner about memory. because that's often been a problem, particularly on Windows, where the debug and release memory allocators are in different libraries. So there's little things like that. I mean, there's a few places where we return we take in an unsigned number of, say, bytes for something, and then we return a signed number of bytes, and that throws away half of your type's size, and also creates a whole bunch of casting issues inside the library where the compilers complain depending on whether it's the word size of the machine, and like there's overflow issues. So we want to not do that. We want to kind of change some of that behavior. I'm okay with having the things return an HIDT for, say, like, H5D create, because that would be changing a lot of code, and technically that's just one value. I do think we should stop checking for like negative values for that stuff, but H5I invalid hit is a fine value to be one special case. Yeah, so there's a bunch of things like that I think that we should also. I think that we should finally remove all the deprecated stuff. Right, we've had H5D create 1 and 2 around for a while, and it finally got really silly with H5O get info 3 in H5O with the vol stuff. So I feel like all the old versions of that we've declared deprecated should actually go away in HDF5 2.0. We'll keep the compatibility macros around for the future because that'll happen again, but we should actually remove the stuff that we claimed is deprecated. But yeah, so there's other things too. I feel like we should investigate Swig as a wrapper for some of the things. I think that we spend too much time, curating Java wrappers and things like that. I think that Swig has matured, and so I think that many of our earlier concerns with it may not be valid anymore. So we should investigate that. So there's things like that I think we should do. We should also consider what we're going to do about the C++ libraries. Do we keep those around, or do we tell people to use these header-only implementations that are designed more around modern C++? So I don't know. But I'm open to everything, right? But I would like community input on this for what people care about, so that we can kind of decide what we're going to do going forward.
And it's also HDF 2.0, HDF5 2.0 is not to be confused with HDF 6. It's not. It's really an evolutionary step. Rather than sort of
right. The file format basically stays the same, right? Yeah. Like we're not talking about changing the file format into a way where you would say like, oh, this is HDF 6. So it's a totally different thing. So
yeah. Okay. Any other questions or comments? No? Then okay, for something fun. And I love the forum for that because I mean I had something else prepared, but I can now save that for next time. But it so happened. I saw it this morning because I would admit that I do not check the forum on the weekends, or late at night for that matter. But someone actually posted something under the heading, I read that as 9 billion rows per second plus support for all Python data types. And it turns out, so I linked the forum post here, that someone created for some time this Python package called Tablite, which you can read as sort of a pun or a spin on SQLite. And there is a nice tutorial, and we will look at that in a moment. It's just a Jupyter notebook that comes with it. And then we'll quickly talk about, because in the post itself, but also in the notebook, the author mentions that he uses HDF5 sort of as the backend store. And that, of course, got me interested. I thought I want to see how he represented sort of this type of tabular content in HDF5. And we'll come back to that in a moment. But let me open his tutorial, which is actually very interesting. I actually downloaded it and ran a few lines, a few examples from that. So yeah, it just pip installs. So you can just, if you have a reasonably new version of Python and so forth, you just pip install it, and then you import table. And here he gives an overview over types and the kinds of operations that you can do in tables, including saving something. So if you see something like this, this is sort of the typical Python view thing, or if you remember in pandas, if in pandas you want to store something as something, you say to underscore HDF5 or to underscore CSV or something like that. So this is very consistent with things that a lot of people are used to. And yeah, you can first of all check versions, and then he has this concept of a storage where I imagine the same is true from SQLite, or that is inspired by SQLite, is that if you have a session, you can actually save your, call it your workspace or your session. So all the tables that you can create for a table, you can set the save property, save S-A-V-E, you can set that property to true, and that will automatically ensure that when you close that session, that the table will actually be stored, so that next time you import that module, all these tables are still available to you. So very convenient. And then, as we will see in a moment, these tables are actually persisted in an HDF5 file. And so that then piqued my interest of what does that file look like. But before we go there, so I think the interface is very Pythonic, very intuitive. You define a table and then just add columns to it, and you can print a table, and you can add the columns sort of as a heading first, and then add rows to it, which is slower because, as we will see in a moment, he uses sort of more of a columnar storage. You can import rows or entire tables from CSV files, for example. An example is shown here. And do all kinds of other things. You can sample tables, you can concatenate them. And then what's also interesting here is to have these mixed data types. And he has a little bit of a, what should I call it? Sort of aggressive way of putting it on his website. Actually, let me quickly go there. On his GitHub page. Oh, he must have responded. Go ahead.
Cell? What you showed as cell. Okay. No, I'm showing. I want to see on his GitHub website. He says something about comparable packages. This is what he says. Oh. He talks about we're all tired of reinventing the wheel when we need to process a bit of data, and he talks about pandas has sort of huge memory overhead when the data types are more than just sort of plain integers or floats or something like that. NumPy, of course, is getting pretty involved, and you have to read up on it and sort of get the idiom, so to speak. Arrow, that's the arrow format isn't ready, in particular for these more complex types. And then I don't know what the background of that user is, which kind of domain science he is in. SQLite is great, but it's just too slow, according to him, his words. And then, of course, if you think about Google protocol buffers or something like that, that's just a he says overkill, and we still need to implement the analytics after that. So it really takes care only of the storage or buffering part. So I'm sure he can back this up, but some pretty aggressive statements. Anyway, so this tutorial is very interesting. So long story short, what piqued my interest is, and he mentions actually, if I search for HDF5 on this page, there is one mentioning Tablite now uses HDF5 as backend, so that's in the latest version. And then he mentions twice that it's sort of backed in storage by HDF5. But if you look at this tutorial, you actually nowhere see to HDF5 or something like that. And I thought, okay, so where is that? Where is that magic HDF5 file? So what I did is I looked at the code, and if you look at the code, actually, did I close it already? No, I didn't. So let me go back. There is in the source code a
a configuration file. So if you go to the GitHub repo, Tablite, and then in here, there's a config.py where sort of the configurations are set, in particular the default encoding to be used for strings, the size of pages, we'll talk about that in a moment, but then here is this H5 storage. So this is basically, so temp file is a module in Python, and you have a default directory where temp files are being generated. So on a standard Unix system, this would be /temp, but it could be something else in other environments. And then, so let's say this is /temp tablite.hdf5. And that's where it was indeed located. So when I looked around on my machine for that file, I found it. So I just printed the output here. So if you do a from tablite config import h5 storage and print it, it returns POSIX path /temp /tablite.hdf5. And then I ran just h5ls on it. And when I ran h5ls, it pretty much returned this list of groups and data sets. So it's sort of interesting, and that's why I would call this, it's sort of disarmingly simple and effective. But the relationship is pretty much, okay, for each table that you chose to persist, he creates a data set. And one of the peculiar things that struck me initially was, okay, well, it's a null data space, which means that it doesn't really contain any data. And that makes sense because, unfortunately, it would have gone, I encourage you to run this anyway and then run h5 dump on it to look at the data in detail. But what I can tell you is these are really just metadata placeholders. So he uses a null data set, and when you have a table, then you have to think about, okay, what are the columns of that table? And so what he uses is basically a null data set just for that table, and he decorates it with attributes. And then in the attributes, if you remember, for example, in the dimension scale standard in HDF5, where you store object references to the dimensions, to the data sets representing dimension scales as attributes of those data sets. The same way here, he uses an attribute called columns, where he basically lists the names or the path names of the data sets representing the column of this table. And so that would be, let's say, for table 1, under columns, under the columns attribute, it would say /column /1 /column /2 /column something. So this data set leads you to a set of columns. And then you see, again, there isn't any real data here, because when you arrive at the column, you are then asking yourself, well, where is the data for that column? And then again, he uses this approach. That's why I think that's part of what the merit of this library is, that he can do this incremental processing. He basically breaks the data into pages. And then so the question is, for a given column, where are the pages associated with that? And if you remember, a moment ago, we looked at that config.py file, where you can set the maximum amount of data to put on a page that's configurable, but the default value, I believe, was 1 million. So that's how the data is then broken out into pages. So let's say for column 1, it would say pages. There would be an attribute called pages, and the pages attribute would then say, okay, it's /page /1 /page /2 and so forth. And then when you come to this data set, that's where the real data is stored. And so in this case, since I just used his Mickey Mouse example of a table with 3 rows, that's why this is the number of rows. In this case, it's the number of rows of the table, because the pages are so large that the entire column actually fits on one page. But if you had a table with a large number of rows, then generally speaking, yeah, you would have multiple pages for a given column. And it's really, it's amazing, it's effective, it's amazingly simple. And yeah, so I think on his GitHub repo, he has more material about the performance. For example, if you look at that Jupyter notebook, if we go back there, he has a performance comparison near the bottom of that, where he compares how long does it take to write something. So for example, he writes 1,000,000 lists with 10 integers each. This is how much memory this consumes. This is how much time this takes. He writes 10 lists with 1,000,000 integers each. This is how much memory it takes. This is how much time it takes. 10 lists with 1,000,000 integers in arrays and so forth. And yeah, you see, compare that with table, that's Tablite. Table with 10 columns with 1,000,000 integers. And this is, it's amazing to see how much reduced that memory footprint is. And okay, so in the first attempt, the time is not that great. But then, yeah, if you take 2 tables with 10 columns with 1,000,000 integers each, then, yeah, you see all of a sudden that gets a lot faster. And so he says, yeah, conclusion, it dropped from 100 megabytes to 3.5 megabytes by using Tablite tables. So it was just a great thing. And he has, what I'm curious about, in his forum post, he mentions that, yeah, he can deal with arbitrarily complex types. And in the forum post, he has a screenshot of some sort. Unfortunately, it's low resolution, so it's this one here. It's low resolution. It's really hard to see what he is doing here. So I asked him if he could send a higher resolution example so that we can look at that. But and I'm sure, yeah, maybe tomorrow we'll see something. But yeah, very interesting, and another good example of there are so many good things out there that we just aren't aware of. And but nevertheless, yeah, people in the community are doing great work. Okay, and unfortunately we are out of time. Thanks for coming, and we'll be back next week, and more new great things.